Hello, and welcome back to another video of Spider-Man debugging. So, I don't know, we've gone halfway in. We'll see if we can get in the whole way. Nah, I'm not drawing this, but this is just where it happens to be. So, I think the last episode I had been working on kind of decoding what this code was doing. So, not even just this function, but if we step back a bit more, just to make it consistent, are we stepping back? Yeah, so this is what we were stepping back into. So this checks unknown to byte. So looking through that to kind of see what's what, and I'm kind of getting an idea of what's happening to start with. So to start with, we're loading a bunch of stuff, and we're storing some stuff in memory, and the stuff in memory will become important at some point. But and then we're kind of doing a loop, and we're doing a loop based on the CO, which is one of the bits in the room file, I guess, one of the bytes, I should say. This one's byte orientated. So we loop through. This first loop kind of describes the helicopter and the dimensions of the helicopter. And the second loop does a different thing. So I had been kind of stepping through that, and that is basically calling into this function here, which is doing different things. So here we are storing things in a slightly different format. So instead of storing I can't recall what it was, and instead of storing something, we're storing a memory address to another table that's got some more information that we'll look up, and this table looks up stuff in a different file. So there's move a tab. It doesn't look it up as you do it, but it kind of loads it into memory and stores it, and reads just where it's stored and just the bytes it needs. So it does that, and we basically get an X and a Y, but kind of offset by a bunch of stuff, and don't know why, but that's just what happens. I mean, at some point I might work out what that is. It's probably the width the enemy can move, I guess, but it could be anything. But yeah, I don't know, stepping through the assembly is my kind of way how to do it. And while I'm doing this, I'm kind of building up some structures up the top of things. So here's kind of what the current state of memory is. Maybe I'll bump this up a little, just to make it a bit easier for anyone else watching. So the first structure was it had 2F as that's just the first byte of the room file, the leftover bytes that haven't been decoded yet. And then it basically has an X and a Y taken from those 2 bytes, but ended with some bytes. Then we have a index into a file, which is a memory. Well, it's really just a memory address into that file, not an index. But it's an index into that file, assuming it's a 3-byte struct, which is what it kind of gets treated as. I kind of say what it is here: 3 bytes, a delta X and a delta Y type. Who knows? Probably says whether it hurts or stuff like that. Could be quite interesting to work out exactly what. So yeah, the memory. So yeah, the second one kind of does this. Has the same kind of XY, but this is the second byte, and I guess this is enough. The fact that it has the high bit set, which this one doesn't, is enough to know what to treat the rest as, because this last one is not the same as this one, which was a kind of dimensions or number of things you should kind of get from here. This one is an address, BP plus this amount, so, and that kind of ends up down here, and say it's BP, but we'll just call it BP plus 32, and this is the address it is. So it kind of starts with a 4, and then has like a quite odd address dereference and doing stuff, but what I've worked this out to be is it's just x plus delta x plus the bottom 3 bits of the type, so it's kind of like a 10-bit number, I guess, of a delta x, but also delta y is done the same. This doesn't really say the minus a, so I might have to like double check this when I'm kind of going through and codifying it up fully, but good to kind of take notes and see what you're thinking is at a given time. And so this is the bottom 3 bits, so I guess that's the amount that you could subtract off both of these to get something. I don't know how it is. They know why it's useful, and then it kind of ends with a static thing, but it kind of goes more, so we haven't actually finished getting things, so I've kind of got to this point here, and we write to like 2f and 30, 31 and 10, whole bunch of places we read from things, but that's kind of in between here and after here, and yeah, we'll work it all out. So I thought what I might do is kind of get back to going through it. Now I'm kind of doing it a few different ways. So we've got the DOSBox X debugger kind of running here, and we are currently broken at a point where we've just moved A9F3, which is this one here. So we've moved this in, and we're just about to kind of read from the BX plus 3, and this hopefully tells us it's EC4O, but we're only going to get the CO. So we're at this point here, and so I've kind of gone 2 lines ahead of that, but yeah, I forget which it is. So if we do help, we can see what is at the end. F10 is step over, and so I want F11, which is trace. So here we can see AL is CL, and then we get the byte before it, which is 1. So that's not what I kind of noted down here or kind of noted here. So it's good to kind of go back over things to see where you messed up. And so here, I can either use the debugger to see what it is and see it's 1. So I can even just say, yep, sure, that's 1. But to confirm, I can go to an address, and I've called it unknown static table. If I go here, this is where it is, but it's offset by a bunch of stuff. So it was offset by 30. So this is to CFF, so we want this to be 2D2F to start with. So this is where the base pointer would be, and then 3 up from here would be the CO that we just read, and then 10 would be the one that we're just reading here. So I'm fairly confident that is the right place in memory. So it's kind of like a static table, which is probably how I'll codify it up in C. But we'll get to that in a bit. So now we've done this, we kind of want to do BP 2F 2F equals AL and BP 0x 30 equals AH. And so this was, it's kind of, so what was it offset by? We get that unknown static table, and it's, I think, kind of offset by I, and these types are probably going to be big, I guess. But I don't know. So we offset it by 30, and that is something by 2, and it's 18. So this 18 is this just AL, and that was like divided by 4 at some point. So that's like getting, oh gosh, so it's like kind of getting a different mask. Did I work out kind of what that's kind of signifying, that 30? Maybe that's the range of motion there, and if it was higher, nah, surely that wouldn't be an index, though, because it's kind of used straight as an index, and you could have kind of a large thing, but potentially it would kind of work. Because it's did that like mask not kind of meet that? So 877A, and if we add that with 60EO, and maybe do a hex of that whole thing, so that is just 60 down the bottom, so we kind of lose the top half. Yeah, I kind of wonder what that means. But yeah, so it's an unknown static table, and the index is kind of a weird thing. So the index that we're kind of using is, we get this. So it's just divided by 2 at the end. I don't know. It's kind of like the first and 60 divided by 4. Divided by 4. And so is this AH0 actually kind of set explicitly in this whole thing? So we shift right. Oh, maybe I did a whoopsie. Because this should be AL. No, where are we? So after doing this, AL equals 60. Is that just I mean, that's what it is, but it's kind of these two things. The 2 bytes kind of ordered together, but so it's that, and then add on the second and 18. Is that what we do? No, it's EO for the second byte, so that second byte gets EO. And this is done before that is divided or anything. So we don't have a first or anything, but we can make first 8, 7, second equals 7a, I guess. So we get that. Maybe instead of the divide 4, I'll do shift 2. Just I would have thought that would get the same answer. I've got a, yeah, I want that one. And so now if I do shift 2, no, it still gets the wrong thing. Well, I guess if I do shift 2 and then all that, and then maybe you want me to have that. Yeah, so now we get that, and it's hasn't converted it to a double. It's just what it is. So it is that so far, and this is, if we look at that, that's just the 60. And so now it like kind of just divides the bottom half by 2. Wow, it divides whatever's left by 2. I don't know, it does some random stuff. Like it's hard to tell because AH is, it's just 0, so it's kind of hard to tell in this case here. It will be kind of interesting when it's not 0, just to see kind of what things would get. And what is the mask 0x60 here? So it's just got like kind of 2 bytes there. So it's just not the last bit, which we know is there. So it's just the next 2 bytes down, and we don't have them. Alright, so that's kind of just like another kind of mask, but it's just used as part of a offset, and it does like a multiply by 2. Is that because we do just add it to each other? Yeah, so I don't know, I'm just trying to work out what the index for this bad boy is. Ignoring the fact that it does this, like the upper and lower, which I will have to take into account maybe. I don't know if it like makes a difference. I'd have to think of the mass. So if, say, it did kind of, if first did match that whole thing, so first is now that, what does this bad boy work out as? So yeah, it just would all end up in the AL anyway, so AH must just become I've got like an AH equals 0 there. I wonder, I need to get out of insert. Give me mouse. Cool. Cool, so AH equals 0. Does that actually exist after shifting AL? It does. So AH does equal that, and then I think it. I suppose it will just be kind of already set. So AX is just definitely this whole thing divided by 2. Well, divided by another 4, but then multiplied by 2. So it's kind of divided by 2, I would say. So this whole thing, shift right 1, doesn't get us the 30. But first is changed, so let's put first back to 87. So that gets us the 48, and that's our 30. So yeah, that's our index into this unknown static array. So this is first and 0x 60. How do I want to do this? I want to copy, paste this from there to there, and do this, and do that, and maybe do, yeah, YS to there, and put that, yeah, except not to there to there, and then this one was plus 3 because we were getting it from 3, and this other one was a H, and then plus 4, and now I can kind of yoink these and kind of throw them back up where I was putting BP stuff. And we can kind of do this and do that, and the memory address don't know yet, but it will equal something there, which will kind of look it up. Where's that go to? That just needs to be that. And so the memory address for this bad boy, we can kind of see. For the BP plus 2F, it is storing at 931B, I guess. So if we do a print of BP plus 2F, how do we like print things? Maybe this debugger is not quite what I want. So the BP is EC, it's 92EC, and we want to add on 2F, 2 BP2EC plus 0x2F, and if we look at the hex of that 931B, and so that would be in here, 0x931B, and does that kind of make sense? So we're adding on a single one here, which looks correct, and also one there also looks correct. And so this one will be 0x931C. Cool, so it sets it to that, and this is currently, so AL was the first one, so that was 0xCO, and this was 0x01. Cool, making some progress. So we were back down here. I should just jump to the end of the file, I guess. Cool. So we get those two things from there, and we store them there, and then we store 0. I could probably just put that there. BP 0x31 equals 0, and that was static, and yeah, we can do this, so plus 0x31 and 0x93 1D it would be, and this thing is just static. And I guess that just ends this table, which, I mean, it has some gaps in it, like what is here and what is here. So this was really 2 bytes, wasn't it? Surely must have been. So it's U8 there, but no, it gets a byte from that. Yeah, so this is O2, so this is like E to F, and maybe I'll just make that like that, and this can be that, and maybe these just single byte ones, and now we can do this. So I'm just doing a formatting just to make it look a little nicer. And if we do that, and so this would be like E to O, I can just work out what that means. Yeah, I mean, maybe I can say that and do an extra couple. But yeah, we don't have like all of this stuff in between here and in between here. And these bytes, and we can go back down here. Alright, so what do we do now? It looks like we recurse, so because we call this sets BP bar, and was that not what we're in? No, we're in the BP plus equal. I called them weird ass things, but it is what it is. Golly, and now we get a memory address from the first word of this bad boy. Cool, I can do this, so we can get bx equals this thing here, but plus 0, and perhaps we can see where that is if we look here, but we were going down like 30, so down to 2f. We get E4A4, and like, is that what happens? And I didn't want to do that. I wanted to see what happens if I go F11, so I did all of those. So here is A4E4, so we go that way around. So this whole thing will now become A4E4, A4E4, and that's like just a static thing. And we were reading this from A2, AA2, 3, so we could potentially work out where this is now pointing to from star AA2, 3. But we can also, if we step 1 and then do data on, we want data segment and bx, we can see what the bytes look like, and it's like 007F0020. And if we go here and search for bytes, and maybe we can come out here and we want to search for I know that string 82800207F0, and it does it like kind of backwards because that's what it does, and it finds one thing. We're not in there, so cool. If we close that, so this is kind of where we ended up, and if we do some mathematics, we can see that So we're going up from where we were, and if we go to unknown static table, and so is this where it was reading? No, because we were like up at 2F, and is that what I had marked? A4, E4. So from here, if we were to go up a bunch, so we want A4, E4, and then we subtract off AA23, which is where we currently are, we get a difference. And I would have thought, no, that is correct. So we want to go backwards in memory, A4, E4. So they'll get us a difference, and that means that from our current address, the AA23, we want to subtract off whatever this is. So, and for those interested, it's 53F. So if we did this and do that, and then we want to subtract that off AA23, and we should get another address, and if we get that, it's A4, E4. What has that told me? No, so the AA23, that's where we are, and what the code tells us, but it got unpacked at some point, and we're actually at 2D2F. So if we do 2D2F and subtract off that, and then get the hex of that, we should get 27FO. And if we did that search again, does it have our recent one? Yeah. So if we did that search again, 27FO is where it ends up. So I'm fairly comfortable that that is MG Hydra is 10027FO, and we could potentially mark it as a thing. I don't know, because it's like a structure. It's not really, yeah, it's we can also see what it is going on, but we can confirm stuff closer to the time. What we want to do is now we want to get a byte from that, and that'll be the next thing we do, and we're saying we're getting 7F, and if we jump forward, the first byte in is 7F, but not the 0th byte in. I would have thought it would get 0. Well, yeah, actually, what does it get? It does get 0. Cool. The 0th byte is that. So what are our things that just happened? So we can go AL equals star BX, and so this now equals 0, 0. It's just what it is. And then we set that, so BB 10 equals 0x10, is it? Should make sure on that. Yeah, it's 0x10 is different from 10, and this equals AL. So this whole thing was this, but dereferenced. So it's that whole thing, but U and H T star. And then star of that, and do something like that, and maybe wrap that whole thing like that. And can we go up to there, and plus 10 is somewhere in here. It's just a single byte, and where are we writing it? So it reckons we're writing it to 92FC. That looks like it might be correct, 92FC. So like from 5 to 16 is 11, so it should go up 11 things, and C is 13, and from actually no, from C to 1 is 12, isn't it? Am I failing at my math again? So 10 to 5 is 11, and FC to 0xf1 is also 11. I was just kind of failing at things. Right, so this whole thing is equaling 0x0, I believe, was what that whole thing kind of ended up. And then we're going to step along. So move that in there, and then we increment bx, and then we call another function. Cool. So bx plus, so now it's just pointing at the next thing, I guess. So A4, E5, and 1027 FO. It's just what it is because it got unpacked at some point. But that is now 1. But now we're calling another function, and we forgot what it is called, so we can just call it fun 3E D4. And that's what it is. And what does this do? So yeah, I'm wondering what that does. No, so this is just kind of filling out the rest of the BP. So at this point here we have a BX, so it's like kind of the pointer to the thing after where we want to look at. So we can even kind of say what that is. It's that plus 1. That whole thing plus 1, and we are setting BP 0x29 equal to BX, and that is that whole thing. So 2 and 9 is somewhere in here, and plus 2, 9 equals yeah, I guess it depending on what it's called with, it's just going to be the index, like I pointed to the index, that's alright. These tables are a bit odd, I guess. So where is this 2, 9 kind of looking? We haven't stepped in yet. So the 2, 9 is 9315. I want that one there. I forgot it already. My thinking how to do I3 things. 9315. And this is going to equal BX, which is A4, E5, A4, E5. And that is just what it is. It's, actually that didn't have one yet, so it's just that whole thing. Right, so if we go back and we do this kind of a few things, we're kind of saving the registers in a sense, because now we're actually no, where AX equals BP1, so we're getting the first thing of BP, we're getting this thing, cool, and then we're storing it back, but at a higher address. So I guess we're making a copy of it. So I could even say this is BP1 because that's just what it is. Plus that, and that's just what it is. And these things are words. I know how to say words when I'm thinking sometimes. I should have a drink. It's kind of warm in here. I left the heater on when I wasn't in. Not for long, but heats it up. Cool. What address would this be? This would just be that would just be this, but add one to that and add one to that. Wee, look at that. Alright, and now we're getting AL as B3, and we're kind of setting that to D and E, I guess. Or just D actually. And so that will just be 8. And it will be BP3. And then we do AH as BP4, but that gets moved into E. Which, I mean, it's just it might swap the order, I don't know. We should probably put these things in, just so I kind of know that I did them. 2D equals BP 3, but it's like U8. Maybe I'll signify like that. Is that what I want? I think this is good, and then we're doing another byte for that. It's just the next one up. Yeah, and then we're up to the loop, and so the loop is just looping while AL is not 80, and the whole byte has to be there. So we're kind of just looking for a stop byte now, and this is getting a thing from BX, so from the table and unknown static. We're basically going to loop through. So did I have it, I'm pushing things in. Was this the table that I was kind of thinking it was? The unknown static table to blah blah blah, offset by a bunch of things. 27FO, this looks like the one, this is the where BX kind of gets set to. We plus it, so we're kind of pointing at the next one, so 7F. And then we're not really caring too much about that until now, and so from here we're looking forward until the 80, so that kind of loops. While AL equals star BX, it's BX plus plus. Wow, it's actually star BX, and we while that not equal to 0x80, we'll just do bx plus plus. That's kind of what it is. And now we get a thing where bx, this counts 1, 2, 3 more, 3 more from before the function was called in this run through. It might be different in a different run through. I need to do this. So that's what that does. And it will increment bx no matter what. So the bx will be pointing at the one after. So because of that, I might actually change this to do something like bx plus plus. We can just do something like that. That's just what it does. And so if we do that and this, not there, and now we call another function. So that's the in fun 103d4. So this kind of just sets like some interesting things, but it's based on the bx and then BP, whatever was existing. So it's kind of like copying existing stuff. Needs a couple of copies, but memory is expensive. It's funny. Right, what did I decide on here? I've labelled this a little, so it means I have been in here. So what's this looking like it's doing? It's using the BX that we have now kind of looped until it's just after that. I kind of want another listing window. Is this kind of possible, or can I open this in like a new window? I kind of want another window of what do they call this? A listing. Another one. No, not possible. Because I kind of want to see what the stuff is. Like this is kind of where it is, and we get to the 80, and so we're looking at this 82. I guess that's kind of what I want to see. So we'd get 82. We'll get that. We'll like move that into 14. So yeah, I guess we can kind of BP. This is now fun 100 3ED8. So this first gets well, like the AX, we can kind of just see what it does. So we get BP 14 to 0x14 to 15 equals star BX. that's just what it is. And then and that's U16 star, I guess, and then that whole thing would get plus. Like we're adding two things to it. I don't know if that's clear. And then we want to do a test of whether BP 0x10 is equal to 10 and 0x2, whether this is equal to 0. If it is equal to 0, then it does a little extra stuff, otherwise it doesn't. They kind of continue this up. Right, so at this point here, what do we have in our BP structure? BP10 is 0. Interesting. So if this and this equals 0, which it does, then we get into this, and I have a comment, where is this used? Maybe just here. Sometimes you never know. So now we are reading BX, and this is going to be the same thing. So it's really just this, except we're doing like 93H2 and 9382. We don't have it stored in our memory map anywhere. Hopefully we find out where it gets used at some point, but I guess for now we just have to kind of put it in 9382. So we get into this, the 993. After there, it's the 4 here. So this is just the pointer of that. Like it's kind of like a weird thing. And this is just going to be the next thing read in BX, which is next word. So we've already read one word. So if we look at that, we read one word, we added it up. So we're pointing just past the 80. And then we read this 82A5, which could be an address. And then we get this double zero. So this is just zeros at the moment. And perhaps we can confirm this. So what were we doing? Have we jumped in this? So 29, I think. Yeah, I'm still a ways off. So maybe if we step this, so we'll do that ink. Then we're going to do a loop until we get to BX pointing to 80, which is now, I guess. No, the bottom one. So yeah, now it's pointing to 80. And so we get out of there, and then we get this. So AX will become A592. I didn't actually note that down, what this actually was. So this would be A582. Is that right from what I reckon here? That is kind of right what I reckon here. And we can see whether that kind of gets stored there. So step and step. And so we could look at D and well, we can see what it is. So it is A402 at the moment. Would have been set from one of the other rooms, but now it's A582. Perfect. We add that, and then we test this thing, and it's 0. So we, reckons we do jump. Right, so we did a jump there. So we're doing a test. So the test is going to get the byte from this, so from that point, which even it says is 0, and then it is going to end it with 2. Which should be 0. Yeah, so it is 0. And this is jump if 0. This is probably the wrong label. It should be that. So if we're equal to 0, we do this, but we're not equal. Not equal. So we down here, so we get cx equals that next address anyway, and it was just zeros, 4 zeros, and we do a plus plus. Do we do a plus plus? We don't do a plus plus actually, so this can just be star bx, and that is just 0 0. AL was BP4. Oh my god, they call another thing. We tweaks CX based on bottom 3 bits of AL. That is, I mean, that's kind of what it looks like it's doing, but it's a funny name. Right, so we have jumped, we have set CX to 0, easy, and AL we get the whatever BP4 is, and did we have it saved here? We had it saved as 0, and it's kind of the type of the enemy. Maybe note that down. Mod 07. I just need to close the window. It's getting a little prickly on the face, and better sitting in the heat. The heat is off. It has been for quite a while, but yeah, better than sore face. Right. So we are going to go into this thing. So we want to step into, so this whole thing. So we can potentially kind of work this out. I guess this was 0. We can confirm that AL is 0, and this only looks at AL. Perfect. So AL is 0, so that should be reasonably easy to reason with. If AL and 1, if it is equal to 0, then we do a jump. So we'll do a jump to there. And so this is like, I kind of want to label this after not equal. So just like how in this that was after equal. So yeah, I think this needs to be not equal. thing is kind of the same. It's an after and it's after not equal, because if it's not equal to 0, then it won't branch and it will do a thing. This is after, this is not equal. Cool, so if we're jumping, so we do this and we do another test and we jump, we do another test. So this is kind of just testing those bottom 3 bits. So these are just 3 bits of an enemy. So if we look at the binary of 7, it is the lower 3 bits are on. So if it does that, then it does some things with CL and CH and whatnot. But in this case, it hasn't done anything for us. So it should do nothing if we kind of step through this. We'll jump, and we'll return. Cool. So, and if we look back at the call site, this was BP4. I want to say this is now fun 100. This and it is 41AF, 41AF, and 36 based on bottom 3 bits of AL and L has no change. Cool. So I don't know. That's just what it is. It's very pseudocode. Like, this is kind of the first pass for me. I kind of write down what I think is happening. I step through, try and see what's happening, and then eventually I'll kind of write more pseudocode-like, and maybe even actually codify it up in a language like C, which is kind of what I've been working in. Doesn't have to be C, but that's just kind of what I picked up and ran with. Right, so where did this end up? Right, so we just called this. So we should be now testing if BP 0x10 and 0x, not 2, 1. Not equal to 0. We do some things, and I think this is another case where our BP structure had that as BP. So what number was it wanting? It was wanting 10, and 10 was just 0, and it's kind of the first entry in this static table, which is indexed by kind of those 2 bytes, but the top 2. Cool. So what did I say in this other loop? I just say NE. I'll just say NE again, I guess. Alright, so we don't do this. Well, we will do the jump because we will be 0, so we'll come down here. We set BP 18. BP 18 is, well, actually no, we CX is plus equal to whatever BP 18 is. So I wonder what plus 0x18 is. We haven't actually written this. Interesting. Like, when did it get written to? Interesting. I kind of wonder what DS BP plus So this, and if we add 10, we would be down on the second row, the E to the F. And so we are looking at 18, so this would be, you know, like roughly in the middle. So maybe if we do, how do we do this? Data for data segment of BP plus, I mean, we can just look at what 18 is. BP plus 0x18 is like just everything defaulting to that. Is that just like not? Oh, it just hasn't added in the thing. This compiler is a little clunky. So 92EC, that's our base pointer. If we want to add 1 to it, that would be D there, and then 8 would be like a bunch of things. So DF would be 3, so to 0 would be 4, and then this would be E, and then we would add another 4 to get that, but it might be 5, I don't know. And so like, I don't know, it has data, but like, I don't recall when I wrote that data. I can set a watch point for when that data gets written to in, so what I can do is set a breakpoint for, no, I want to set a breakpoint for code segment IP. It's in GDB and LRDB and pretty much every other debugger I've used. If you just type breakpoint on a line that you're currently at, it will set a breakpoint for that point. But if you do it in Xdebugger, GDB, DOSBox X, it will set it to 0, 0. And so you actually have to say, I want the code segment IP. But yeah, so I'll do that, and let's see what the watching addresses kind of do. So we do that memory breakpoint. So I can do a BPM of, and it says it here, 9304. So it gets it, then it puts it down. So I could do DS. I kind of want to note down what line I'm at the moment. So just after that call site, this is, well, we can bring you over yonders and bring you here. So in fact, the call site was at 3517, and this would be FE6 for the call site, but I have selected the line after, so I'll say this is FE9. And so that's where we are there, just so I can kind of come back in here, because I think I might have to restart the thing, but the memory address that this is looking at is DS of 9304. Huh. That didn't do what I thought it would do. And like, of course, there's no way to recall what you did. So I did BPM, and I want it to be DS, which, like, do I have to type this in for 17DA? That is right. And the address I want it to check is 9304. 9304. Cool. Did I, like, oh, I might have done, nah, I don't know what I did, maybe, who knows. So what I want to do is, like, maybe just go run. Right, so it is changing it from there in a weird place. Oh, it hits us like every frame. Is that? I think this is hitting every frame. Interesting. I mean, it's teaching me a bit about. Yeah, I think I need to quit. Yeah. Oh, of course. Yep, that's right. Cool. So that does all of that. Yeah, it's kind of interesting that it is pulling from an address. Well, when is BP 0x18 written to have something like that as my little comment? So I think I might leave that there. I mean, maybe I can do a little thing, and like before it kind of starts, we can did we say what BP kind of was? Well, it's wanting BP 18, so I can kind of work that out. BP here, so that's read at some stage. Unsure when written, but what will it have in it? It will have this address in it, but it would have what, 8 more than that. Is that right? 8 more. So if I had there, then 8 more, 8 more, 8 more, yeah, cool, 8 more, so that is the key. Cool. And does that seem right? D, E, 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So U. Oh, yeah, not that much. Didn't think 8U would do quite that. I just want. That cool. So I guess now I can go to BPM, and I want this to be in the data segment. But is the data segment the right place? Where do you say data segment up there? Golly, 170. Yes, I think that was what it was before. And so we can go 9304 and see what that is, and we can also break at kind of this point here, and if we give this a whirl now, we're now running, and if we run that, it's still running, and it's now broken at this point. I wonder, so maybe we can use there. I wonder, so this is when we've just hit that code point. Bizarre. So it's kind of treating it as if it is 0 to start with, so it must be 0. It seems 0 initialized. And I wonder if this is the first time round that we're kind of reading the two things, and I wonder how we can kind of test that. Like, is this, which level is it on? It's kind of before it's doing anything, so I wonder if this is like a pre-run. Anyhow, we've done a few bits of things. So we check if it is 1, it is not. So we're pulling in just 0, then we're adding 2. So yeah, I guess next session I might run through in the point that I know that it's kind of in the state that I'm reading the right 2 bytes. To then reason with what happens kind of next. And so what does kind of happen next? We have not too much more in this thing. There's like a jump, and that is a loop, if you ask me. No, that's just a return, so maybe I might just label that ret, just to make it a bit clear what it does. So we get here, we do this, we do a bit more writing of things, we get another address. Now this could be an interesting one. We'll have to work out where that is. DOSBox X will help us with that feat. Do a bit more things, and then we return out of this function. And where did this kind of end up before we even call this like fun one? Yeah, so we're in here and we would be finishing off this, and this looks like it doesn't do too much, and that just jumps down there. It's not a loop. Cool. And then we would have finished this function, which does like a few different things. But that function there is, if we step back enough, it's just the kind of other path in the first loop in this check unknowns 2 thing. So it's the first loop round we did one thing, which was looking at the helicopter going up and down, and then this second loop we're looking at the R2D2, those 2 bytes. And the golly, that wasn't the right one to push. Escape doesn't get out of that. It's not a very keyboard friendly thing. So if I do a dot out display 1, so this is kind of what we're looking at. So the first one was the helicopter, and the second one is this, and like it's kind of that point there. But this guy has like a little bit of range, and I think the other bytes are kind of maybe describing that he can go from like there to there. I don't know, but he is also like a few pixels tall. It is interesting, but yeah, this is all the data that I'm kind of looking at. So we read a bunch. I think it was up to just the 2CAF, and that was the helicopter, 2 bytes. And then the 877A, yeah, because it started with an 8, meaning that it's an enemy, maybe? I don't know. But yeah, I noticed that it didn't, I have a little thing that helps me know when I'm blocking the camera or not, and it didn't actually pop up this session. It popped up on the wrong screen, so it wasn't really helpful at all. But yeah, this is looking cool though. I mean, it's slow work. It's paint drying might be a bit more fun to watch. There's a movie for that. There legitimately is. It was kind of like a protest paint drying movie against like the was it this one? Yeah, 10-hour film. Goodness. Not. There's a 2023 one. But again, it's like it's interesting that it says 2016 there. And yeah, Charlie Shackleton, same one. Interesting. I created the film in there, but yeah, it was like a protest against the censorship and whatnot. And pretty much they had to pay, he had to pay like the, whatever board it was, British Board of Film Classifications, money to watch the entire film, and you paid for time raised. So he raised like a bunch of money and made a 10-hour film. 10 hours of paint drying might be more interesting than me, but who knows. I hope you stick around and watch me. I'm entertaining at times. Cool. I'm liking where this direction is going though. But I think I will kind of stop there just because, like, I don't know, when you get in the middle, when you kind of lose your flow, I might just do maybe 0 initialized. When you lose your flow in the debugger in DOSBox X, it's a bit jarring and it's kind of hard to get back to where you are, just the way DOS programs are run. You can't just respawn it like, say if I wanted to run my thing, and I don't know what I might run. So I could run it, and it didn't work. Okay, can I run it again? Oh, can I run it with some different arguments? But it just doesn't really work with the DOSBox kind of layout. Like, I don't know, like, because like when you have just DOSBox itself, maybe DOSBox X is a bit quicker, but it takes a good minute to load up. A good minute. And I don't know if my control C is going to kill it before it finishes loading. Paint drying or DOSBox loading, which do you reckon would be more interesting? But yeah, I guess like from here, we can have something like, can we just do this, and then where we can, yeah, you do something like that. I used to use DOS like a long time ago. So we have like all our things here. I think there's like a way to, like, how do we get the help of you? Is it an built-in one? No, this just isn't really helpful. But yeah, it doesn't have Alex. Here, like, we can have this Spidey thing, and do we have a debug? Like maybe. No, what I think I want to do is maybe do DOSBox X out of the default, and so we could have something like this, and we could do mount C, just that, and then go here, and if we have a look, and can we do, yeah, so we can't just like go debug, like runs DOS debug. Oh, and how do we get out of DOS debug? It's quit. Yeah, like that. Hasn't done it? I don't know. Yeah, so this is like a different debugger, which is like even rougher to use. Because what I would kind of want is just in this to be able to set a breakpoint that's always going to exist, but then like when it unpacks it, loads it to a different place. I think I want to do that, and cool. I think that's that. I've got some leaks. Do I have some leaks somewhere? Oh no, that's just because I was running under GDB. I should not have leaks. Yeah, I don't have leaks. I just cool. Yeah, I think I've rambled enough. That's probably enough for this video. Is kind of what I'm trying to say. But I'll come back to this. It's an interesting project, and I am quite excited about the final outcome, I guess. Like, the possibilities. Quite literally, the possibilities. But first, got to work out how the file format is read, so could potentially put in some of those possibilities into the files to then use the game engine to do some interesting stuff. But until then, thank you very much for watching. I hope you haven't switched over to the paint drying, and if you have, come back to me and I'll still be working on this. Until next time, have a great day. See ya.